Jamb 2026 candidates, I welcome you all to today's calculation class. Please, if you have any issues, you need any assistance, especially if you're a last minute preparation candidate, please connect before it's too late. I can help you, okay? I can help you. Maybe today I start to help candidates for 9 minutes. I can help you and you are still going to score high. If I can do it within 72 hours, I can still do it within 4 weeks. So, connect, link up. All right, so our topic for today is specific latent heat of vaporization. Please, if you don't have the list of topics where Jamb is going to set calculation questions from, send me a DM so that I will send the file to you. Okay, send me a DM. You need to have that list. Jamb just selected few topics where they are going to set calculation questions from, and that's what we are using to create this lecture that you are seeing. Okay, that's why you can see that some topics are not here. Only the topics selected by Jamb, that's what we are treating. Okay, especially the high yields, mainly the high yields. That's what we are treating here, all the high yield. Okay, so ensure to send me a DM to get your copy and access each and every topic selected by Jamb, where they will set calculation questions from in Jamb 2026. All right, so specific latent heat of vaporization. We did specific latent heat of fusion. Now we are doing vaporization. Okay, the question we have here in front of us reads: calculate the specific latent heat of vaporization of steam if 1.13 times 10 raised to the power 6 joule of heat energy is required to convert 15 kilogram of steam to water. These are the options provided. All options represented in standard form. So we have to be very fast. This is a very, very easy and cheap question. Let's write it out. What we are told to find, given specific latent heat of vaporization. Okay, we put it as LV. Okay, specific latent heat of fusion is LF. Okay, is equal to question mark. So this is what we are looking for. All right. So since we are told to find this, let's do what? Let's write out the formula of this thing where they tell us make we find. Okay, so what is the formula? Okay, we are still going to use that same formula for specific latent heat of fusion. Specific latent heat of vaporization, not the same thing. So it's just to use what you need and make what you are looking for the subject of the formula. Okay, so Q, which is quantity of heat, is equal to mass LV. Okay, this one is specific latent heat of vaporization. This one is mass. This one is quantity of heat. All right, so this is the formula we are going to use. We are just going to make this the subject of the formula and we solve. All right, as easy as that, easy peasy. Now let's write out all the parameters given to us. Okay, the first parameter here is what? Specific latent heat of vaporization of steam if 1.13 times 10 raised to the power 6 joule of heat energy. This one is the quantity of heat. Thereby Q is equal to 1.13 times 10 raised to the power 6. Okay, joule. So this one is the quantity of heat. Then what else were we giving? We're also giving mass. Heat energy is required to convert 15 kilogram of steam to water. Okay, so mass is equal to 15 kilogram of steam to water. All right, so we are looking for this and we want to apply this formula. Okay, since we are looking for this, let's make this the subject of the formula. All right, so LV is equal to, this one will now go up. Okay, it will now be Q over M. Okay, Q over M. All right, as easy as that, chicken up, easy as ABCD. But look at this place. Okay, we have standard form here and we have normal figure here. Can we use this to solve? It's difficult for me to use that to solve. So if I were you, or if I am the one taking this Jamb UTME, I will just quickly convert from standard form to figure. And since we want to convert from standard form to figure, all we have to do, since we have this one here, it's telling us that we have 60. Okay, since the point was located here, we are going to count here, count everything 6. Okay, 6, and we are going to replace any other number that is not here with 0. For example, let's start 1.13 times 10 raised to the power 6. Okay, so we start from here to count. So we put 1 here, points. We are going to start from here, 1, 3. So we are going to represent the rest figures that we complete it with 0. So we count from here 1, 2, 3, 4, 5, 6. So all here now 0 go there here. Okay, so 0, 0, 0, 0. Okay, hope we converted correctly. Okay, hope we did the correct conversion. 1, 2, 3, 4. So from the point we now count 1, 2, 3, 4, 5, 6. That's it. So you will now remove these points because you have converted it back to figure equal to 1, 1, 3, 0, 0, 0, 0, 4. This is about 1,130,000. Okay, 1,130,000. So that's what our standard form is now. We have converted this one to this standard form. So we are going to substitute this as this quantity of heat. So LV is equal to Q over M. LV substitute into the formula. Q is what? 1,130,000. Okay, over what is M? 15. So when you divide, you are going to get LV is equal to 75. That's what the calculator says, 333.33. Remember, all our options are in what? In standard form. So we are going to convert this one back to standard form. So converting it back to standard form, all this one, because they can be approximated, okay, they can be rounded off, you cancel all this one, all these ones don't die. So what will happen? We are not going to be left with, we count from this point, okay, we are not going to count from the point, this point we have here, and convert this thing to suit what we have here. Here is represented with just two significant figures. So it was represented with just two significant figures. So we are going to make our answer like that. So we are going to put our point here. If we put our point here now, let's bring it down. 75. 3. Okay. So we don't cancel all these points. So now here points, then we will start from here count. Okay. So if we put our point here now, for example, we are now going to count like this. 1, 2, 3, 4. Can you see? 4. All right. So we are now going to be left with 1, 2, 3, 4. That's raised to power 4. All right. So if we put the point here, for example, we are going to count 1, 2, 3 to this point. 1, 2, 3. We are going to be left with 3. That's raised to power 3. All right. So we are now going to be left with LV is equal to 7 points. Since you are putting the point here, 0.5 times 10 raised to power what? 4 joule per kilogram minus 1. Please look among the option and pick the correct option. Drop it in the comment section. Still on that specific latent heat of vaporization, we have Jamb must repeat question 9. And the question reads, an electric current of 3 amps flowing through an electric heating element of resistance 20 ohms embedded in 1000 grams of water at 100 degrees Celsius. Take 2.5 minutes to boil off the water. Calculate the specific latent heat of vaporization of water. All right. So the first thing to do is to figure out what we were told to find. But before we do that, let's look at the options. All options are represented with no units and represented in standard form too. All right. So we write out what we were asked to find. So we write given. We were told to find was calculate the specific heat of vaporization. That's that LV is equal to question mark. That's what we are. Now this thing now we define. Okay. So when you look at this question, they gave us current here 3 amps. They gave us resistance 20 amp. They gave us resistance 20 ohms. So this is trying to tell us that this question relates specific heat capacity with, okay, it relates specific heat capacity or latent heat of vaporization with electricity. So we are going to apply both formulas here. That's what it means. Because you can't abandon all these ones, all these parameters. They gave it for a reason. So we are going to have to what? To relate formula. We relate two formulas to get this answer. Okay, so let's write out the formula for electricity. The most common formula of electricity is I squared ROT. Okay, we also have IVT. Okay, we have about, is it not about 4 of them? Okay, just know one. You can always derive the rest with one. Okay, so this one is volt is equal to I squared ROT. Okay, electric energy, sorry, E. This one is electric energy. An electric current of 3 ampere flowing through an electric heating element of resistance. So since this question is talking about energy, we are using this energy formula. This one is electric energy. Electric energy is equal to I squared ROT. Okay, so we are using this formula. So we are going to attach it towards latent heat of vaporization formula or quantity of heat. When you are calculating latent heat of vaporization, we are going to attach both, okay, and use it. Okay, so the formula for quantity, what is it called? Quantity of heat is, since we are looking for this one now, okay, quantity of heat is equal to, they gave us this one, latent heat of vaporization. Okay, that's what we are looking for. They said we should calculate latent heat of vaporization. Okay, so Q is equal to mass times LV. Okay, so we are going to bring these two formulas together. All right, bringing these two formulas together, we are now going to be left with I square RT is equal to MLV. Okay, so this is what we are going to use to solve. But before we start solving, let's write out all the parameters given to us and figure out if we can really use this formula to solve. Okay, the first one is current. We are given current, which is I is equal to 3 ampere. Then flowing through an electric heating element. You can see that I'm reading slower now to write out all the parameters given. Of resistance, this one is the resistance R is equal to 20 ohms. Okay, then embedded in 1000 gram. I don't go give you something for gram now. Gram is standard unit. Gram is not a standard unit, so we'll have to convert. Okay, so maybe you just know that one now. So this one, mass is equal to 1000 gram. So this 100 degrees Celsius is the normal boiling point, okay, of water. All right, so let's put temperature equal to 100 degrees Celsius. Okay, takes 2.5 minutes to boil off water. Time, okay, this one at temperature. Time, which is small letter t, is equal to 2.5 minutes. Okay, 2.5 minutes, that's the time. All right, so all these are the parameters given to us. They said we should look for this. Okay, so if we look at these parameters, can we use this formula to solve? We have I here, current. R here, resistance, we have it. T here, time, we have it. M here, mass, we have it. It's only temperature we don't have. And temperature is already, we don't even have temperature here in this formula. We remove temperature in the general formula. So what we have to do, we can use this formula to solve. So let us convert all the ones that need conversion, like mass and time. The standard unit for time is seconds, not minutes. So that's the standard. So we are going to do this conversion, mass and time. So to convert mass, 1000 gram to kilogram, we are going to do 1000 divided by 1000 equal to what? 1 kilogram. Then for time, we are going to do 60. Since we are converting from minutes to seconds, we are going to times 60 times 2.5 will now give us what? 150 seconds. Okay, so we can now use all this one. So the new one is 150 seconds. The new one is 1 kilogram. Bracket close. So we can use this formula and solve. So when we use this formula to solve, we substitute here. What is I? I square is what? I square 3 square 3 raised to power 2 times what? R. What is R? Times R. What is R there? R is 20. 20 times time. What is our time? Our time is now 150. Equal to what? What do we have here? Equal to mass. And our mass is 1. 1 times LV. Okay, so we do this one. 3 times 3 will give us what? 9. Therefore, our energy, remember, it's energy we are calculating. Energy is equal to 9. We open the bracket times 20 times 150. This one, 1 times this one will give us this same thing. So it will now be equal to LV. All right? Is that not it? LV. All right? So E now is equal to 9 times 20 times 150, 27,000. Okay? 37,000 joule. So this one is our energy. Therefore, latent heat of vaporization is equal to 27,000 joule. So this is our final answer. So among the options are represented in standard form. So we have to convert this to standard form. And all of them are two significant figures they put for there. So to convert this to two significant figures, we have 27,000. To convert this, we are going to have to put the point here. Okay, and when we put the point here, we are going to count like this. Okay, to the end. 1, we count from here. 1, 2, 3, 4. It will not be raised to power 4. So we put point here. 2.7 times 10 raised to power 4 joule per kilogram raised to power minus 1. This is the answer. Either this or this is correct. So among the options, pick the correct option and drop it in the comment section. See you in the next class.